All right, so I made a mistake. I made a video this morning about using trig to do some story problems, and for my students who have watched it so far, if anybody's watched it so far, I kind of stopped my tracks and would realize that I'm talking about angle of depression and angle of elevation and the problems, and I haven't really gone over that with my students. So my students are going to be getting a note sheet that will also describe angle of elevation and angle of depression. But all it is like I was talking in that video, is depression means to depress, to go down, and elevation means to elevate, to go up. So you have an angle of going up and you have an angle of going down. All right, so elevation is up and depression is down. And you have these angles. And what they're based off of is they're based off of either sometimes the ground. So if we're talking about the ground, we can't really go below the ground. So if we're talking about an angle from the ground up, so we're talking about from the ground, or maybe from the sea or the water, or from the ground, from zero up, then I don't know, let's say there was like a tree over here, ugly tree, but then the angle of elevation up to the top of that tree you'd go up, and that would be the angle of elevation because it is up. You have to look up to look to the top of the tree. All right, so just up is elevation and down is depression. Elevation is a really easy one because it's really easy to make the right triangle of an angle of elevation, because all of your right triangles are either going to look like that, or they're going to look like that, or the angle's over there. So it's either going to look like that or like that. It's just from the bottom up, and then you cut it off, right? So a lot of them will be like casting shadows. If you have maybe there's a building, say a skyscraper, whatever, and it casts a shadow that is 200 feet, and it's casting the shadow, and the angle of elevation from the end of the shadow to the top of the building is 35 degrees. So it's easy to make those right triangles because angle of elevation, you just go up, you look up. All right. And angle of depression can be easy too, depending on the right triangle you have to make and how you can visualize it. The difference with angle of depression is you're looking down, so you're not starting at the ground. A lot of these will be like planes. So like when a plane goes to land, I don't know if anybody's ever seen it who's watching this video, but planes have inside kind of like a level. I don't know what the ball is called, but it tells them whether they're flying level or if they have a certain degree of altitude or of elevation or depression. Okay, so when they tip the plane down, it'll tell them how many degrees they're tipping the plane down. So let's do a plane for this problem. Let's say that you have a plane. This is not going to be a pretty plane. Oh man. Okay. There's our plane. All right. Now let's say the ground, right? We got our airstrip. Say we got our airstrip out here. And let's say in order for this plane to land, it needs to position itself at a 12-degree depression. So it needs to have an angle of depression of, oh, I got too many markers in my hand. It needs to have an angle of depression of 12 degrees. How that works is, the difference with when we're talking about depression is you have to draw in this imaginary extra line, because that's the line of sight that I was kind of talking about in the other video. Is you have this line of sight, or this horizon line, but the line is parallel to the ground. That's important, parallel to the ground. So what happens is, if I need to nosedive at a 12-degree depression, is you go down from there 12 degrees. So that would be the angle. All right, this is the angle of depression. Well, usually story problems will then ask you if the plane is, let's say, 12,000 feet, actually let's say 15,000 feet in the air, 15,000 feet in the air. How many feet until the plane lands? All right, so how many feet till the plane lands? Not how many feet will the plane actually travel, because this is the travel, but how many feet away from its position to its landing. All right, this is the landing over here. Well, the issue is, and it's not a big issue because hopefully all my students remember this line that I just dropped is perpendicular, right? Perpendicular is very important. The reason why it's perpendicular is because I wanted to draw straight down, because I want to find the exact measurement from the nose, the very tip of the plane, how far from the very tip of the plane to here. And that you do by dropping a perpendicular and saying, well, this is where the plane is now, the very front of the plane, and this is where it needs to be. So when it drops there, we're good to go. We've landed. So I'm missing an angle here. But I know that this is perpendicular because I made it so it's perpendicular. That's the whole point. I want it to be specifically perpendicular so that I can accurately measure this. Well, if this line is parallel to this line, then that means that this also has to be perpendicular. And that will be true for every single depression problem, every single angle of depression problem. This line is parallel to this line, and this are both perpendicular, both 90-degree angles. Well, if they're both 90-degree angles, then you can do some simple math and remember, okay, what's 90 minus 12? 78 degrees. So now you have your adjacent, your opposite, and I can use TOA, right? Because if I want to find this question mark, I want to find opposite, all right? I can set up, I'll do it over here, I can set up tangent of 78 degrees equals opposite over adjacent. So I want to put an X here. X over 1500. And then you go and solve that by multiplying both sides by 15,000. There is another way to solve this, and this always works. There's two ways, and the other way is to create an upside down triangle by just extending this and just take this 1500. Imagine that this plane just kept going. This also has to be 1500. And then this is also a question mark. You make a rectangle. It's just a rectangle. It's just a cut in half rectangle. And that'll be the same for all angle of depression problems. So you don't necessarily have to find the 78 degrees. You can also do the tangent of, let me grab a different marker so we're using different colors. You can also make this an opposite, make this an adjacent, and do the tangent of 12 degrees equals opposite over adjacent. Get rid of that thing. You can also solve that one. This and this will give you the same answer. There is two ways to solve any angle of depression problem. Again, angle of elevation, way more simple. You just look up. The right triangle for an angle of elevation is very easy. Angle of depression confuses students usually because there's two ways to go about it, and they mix and match the two different ways. Pick one way and go with it. Pick one way and go with it. All right. Both of them work perfectly fine. So really quickly, I'll do another one. And I will base it off of, let's do, a zip line. Let's do a zip line. So let's say we have you're gonna go into your tower. You gotta go to a higher position for a zip line. So let's say, you're in the tower way up in the air, and you're gonna zip line. All right, to the landing. Now, zip lines have a sag to them. They're not perfectly straight, all right? But this is an estimation when we're doing zip line problems. And you're gonna pretend, let me come in here with the red, you're gonna pretend that this is actually gonna be, well, that's not super straight either, but we're just pretending all over. Pretend that it's straight. And let's say that the angle of depression of the zip line is about 15 degrees. So you draw this in, right? This is your line of sight. This is the horizon. It's looking straight on. So the angle of depression is about 15 degrees. All right. Now, the other bit of information you would need is, let's say this is 40 feet in the air. Let's say this is 300 feet in the air. So there's two ways you can do this, all right? Just like the other two ways. I like to just make an upside down triangle. That's how I work. I like to just make an upside down triangle. So I immediately just come over here. I'm gonna draw straight up. This is my right triangle now. Well, that's 300 feet, this is 40 feet, so how much feet did I go down? I went down 260. So the question would be is, how long is the zip line? So about how long is the zip line? Because you went down 260 feet, at a depression angle of about 15 degrees, about how long is the zip line? So how I could do that would be, well, this is the hypotenuse, all right? And this over here would be the opposite. So I'm going to use so, right? Remember, you guys, everybody doing trig should always have SOHCAHTOA memorized. So we're going to use this one right now because we have hypotenuse and opposite. So H and O, H and O, H and O, H and O. So I would set up a sine of 15 degrees equals opposite over adjacent, so 200, not opposite over adjacent, opposite over hypotenuse, equals 260 over h, and then I solve for h. Okay, now again, I'm going to erase this stuff. You do not have to solve it that way. What you could do also is make the non-upside down one and just go up 40 feet and then straight over and make that right triangle. But now what you're going to have to do is find that, which is easy, right? 90 minus 15 is 75. So you have your, again, you have your 260 here. So 260 and 40 make up 300. And instead of doing sine, this one would be cosine, because we still want h. That's the question. But instead of using sine, we're going to use cosine, because this right here is adjacent. So it would be cosine of 75 degrees equals adjacent opposite over hypotenuse, so 260 over the hypotenuse. All right, same exact answer as the other one would give. It's just when you do angle of depression, you have two options. Angle of depression, you can either do the top triangle or you can do the bottom triangle. You have to draw them. You have to draw them. There are very few people who can visualize in their head a picture of a story problem. So if you can't visualize it and picture it in your head, you need to put it onto paper. I hope that answers all my students' questions. And anybody, I hope that helped anybody who's watching this. Again, my students, you're going to be getting notes. Please look at those notes also. You can print them out. If you need printed copies, I can print them out. It basically just has a real quick breakdown with some visuals of what I just went over. Angle of depression, angle of elevation. Those are what all your story problems for this week and next week will cover. You have to know it. All right, thank you for watching.